Now we are going to discuss the relation between coefficients and the type of solution. That is the coefficients of x, y and the constant terms, their ratio and what relation it has with the type of solution that the pair of linear equations can give us. So here we are supposed to find the ratio of the coefficients of the x terms, that is a1 by a2, ratio of the coefficients of the y terms, that is b1 by b2, and compare them. If these ratios are not equal, that is if a1 by a2 is not equal to b1 by b2, then the system is said to be consistent, or they will have a unique solution, that is the lines will be intersecting. Now in case if a1 by a2 is equal to b1 by b2, then we will find the ratio of the constant terms, that is c1 by c2. If c1 by c2 is not equal to a1 by a2 and b1 by b2, then the system is said to be inconsistent, or they will have no solution, that is the lines will be parallel to each other. The third case is where a1 by a2, b1 by b2 and c1 by c2, all these three ratios are equal to each other. Then the system is said to be consistent and dependent, that is they will have infinitely many solutions, or the lines will be coincident lines. So before we start solving a pair of linear equations in two variables, we must first check these ratios a1 by a2, b1 by b2 and c1 by c2. The equation will be solvable only in case of a1 by a2 not being equal to b1 by b2. This is the only case where we can solve the equations and find a value of x and y. The other two cases are not solvable, they can only be represented graphically. So first it is important to compare these ratios and check if they are equal or not. Now in the example which we had taken, first example 2x plus y minus 6 equal to 0 and 4x minus 2y minus 4 equal to 0. Here if we compare the ratios a1 by a2 and b1 by b2, we observe that a1 by a2 is equal to 2 by 4. That is coefficient of x in equation 1 divided by coefficient of x in equation 2. 2 by 4 is 1 by 2. b1 by b2, that is coefficient of y in equation 1 divided by coefficient of y in equation 2, that is 1 by minus 2, it is minus half. So here we can see that a1 by a2 is not equal to b1 by b2. And also we had seen that the system has a unique solution, that is the lines were intersecting at one single point. In the next example, now it is important to first get the equation in general form. The general form is ax plus by plus c equal to 0. So I must ensure that the right hand side is 0. So after getting equations in the general form, the equation is x minus y minus 8 equal to 0 and 3x minus 3y minus 16 equal to 0. Now if I compare, a1 by a2 is coming 1 by 3 and b1 by b2 is minus 1 by minus 3, which is also 1 by 3. Now in this case, when a1 by a2 and b1 by b2 are coming equal, I need to check c1 by c2 also. So c1 by c2 is minus 8 by minus 16, which is 1 by 2. Now a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. And we have already plotted the graph for this system of equation, and we have observed that the lines were coming parallel to each other, that is they will have no solution. In example 3, after getting the equations in general form, it becomes x plus y minus 5 equal to 0 and 2x plus 2y minus 10 equal to 0. Now here a1 by a2 is 1 by 2, b1 by b2 is also 1 by 2, and c1 by c2 is minus 5 by minus 10, which is also equal to 1 by 2. So all three are equal. All three ratios are equal, and we have already observed in the graph that these lines were coincident lines. That means the system will have infinite solutions. So in all the three cases, after comparing the ratio of the coefficients of x, y and constant terms, we have observed that this relation is true. That is, relation between coefficient and the type of solution is justified. So to summarize what we have learned till now, relation between the coefficient, the type of solution, the number of solution, the type of graph and the consistency, we can quickly summarize it in the following table. If a1 by a2 is not equal to b1 by b2, then we see that the number of solutions will be 1. If we talk about the consistency, the system of equations will be consistent and the type of graph will be intersecting lines. The second condition is a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. In this case, the number of solutions will be 0. The system will be inconsistent and the type of graph will be parallel lines. The third case is where a1 by a2 is equal to b1 by b2 and also equal to c1 by c2. In this case, the number of solutions will be infinite. It will be consistent and dependent, and the type of graph will be coincident lines.